Welcome to sureshbhattclasses. We are learning quantitative aptitude topic numbers. All the topics of quantitative aptitude are useful for many competitive exams like Bank PO, RRB, SSC CGL, Railways, and many government job exams and interviews. These topics are useful for all entrance exams like GRE, SAT, ACT, CAT, GMAT and many more. Please watch all my videos on quantitative aptitude topics. In this video, we are going to learn finding unit digit in factorial. So factorial and its unit digits. Factorial 1 equal to 1 and unit digit of factorial 1 is 1. Factorial 2 equal to 2 multiplied by 1 equal to 2 and unit digit of factorial 2 is 2. Factorial 3 equal to 3 multiplied by 2 multiplied by 1 equal to 6 and unit digit of factorial 3 is 6. Factorial 4 equal to 4 multiplied by 3 multiplied by 2 multiplied by 1 equal to 24 and unit digit of factorial 4 is 4. Factorial 5. 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 equal to 120 and unit digit of factorial 5 is 0. Factorial 6 equal to 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 equal to 720. And unit digit of factorial 6 is 0. Factorial 7 equal to 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 equal to 5040. 5040 and unit digit of factorial 7 is 0. I suggest that everyone should memorize the value of factorial up to factorial 7. We should remember few properties of factorial regarding its unit digit. Point 1. 0 factorial is 1. Point 2. N factorial is equal to n factorial multiplied by n minus 1 factorial. And for example, 5 factorial can be written as 5 multiplied by 4 factorial. This can also be written as 5 multiplied by 4 multiplied by 3 factorial. And this way we can memorize that n factorial equal to n into n minus 1 factorial. Point 3. Unit digit of every factorial is even except 0 factorial and 1 factorial. As I had requested you to memorize the values of factorials up to 7 factorial. And as described here, unit digit of every factorial is even except 0 factorial and 1 factorial. As 2 factorial is 2, 3 factorial is 6. 2 and 3 factorial both have unit digit 2 and 6 which is even. 4 factorial has the value 24, that is also even. So every factorial other than 0 factorial and 1 factorial has unit digit even. Point 4. Every factorial greater than 3 factorial is divisible by 4. All the factorial greater than 3 factorial is divisible by 4, as 4 factorial is 24 which is divisible by 4. 5 factorial is 120 which is divisible by 4. 6 factorial is 720, that is also divisible by 4. And all other factorials greater than factorial 3 is divisible by 4. Point 5, it's important. Every factorial greater than 4 factorial has unit digit 0. 4 factorial is 24. Up to that factorial only the unit digit is other than 0. 5 factorial is 120. 6 factorial is 720 and 7 factorial has value 5040, 5040, that is also the unit digit 0. and all other factorial greater than 4 factorial is having unit digit 0. Now we solve few questions based on unit digit of factorials. We go to the questions. Our question is, find the unit digit of 3 to the power 5 factorial multiplied by 4 to the power 8 factorial multiplied by 6 to the power 9 factorial. The given options are option A 4, option B 3, option C 5, option D 6. Before solving this question, I request you to please subscribe to this channel, as we know that the unit digit of any number repeats itself after every fourth power. Also, we know that every factorial greater than 3 factorial is divisible by 4. So using these two properties, we can solve this question. The unit digit of 3 is 3 and 3 to the power 5 factorial, as 5 factorial is divisible by 4, the remainder will be 0, but we will write it as 4 multiplied by 4 to the power 8 factorial can be written as 4 to the power 4, as 8 factorial is also divisible by 4, multiplied by 6 to the power 9 factorial can also be written as 6 to the power 4, as 9 factorial is also divisible by 4. Now 3 to the power 4 is 81, so ones place digit of 81 is 1, multiplied by 4 to the power 4 is 256, and ones place digit of 256 is 6, multiplied by 6 to the power 4. Whatever may be the power of 6, the ones place always remains 6. Here 4 to the power 4, if you don't remember that it is 256, then you can easily find it out, as 4 to the power 4 can be written as 4 to the power 2 multiplied by 4 to the power 2, and 4 to the power 2 is 16, and 16 times 16, the ones place of both the 16 is 6, and 6 times 6 is 36, and ones place digit of 36 is 6. So we can write 4 to the power 4 as ones place digit 6. 1 multiplied by 6 is 6, and 6 times 6 is 36, and ones place digit of the given question comes out to be 6. This way we can easily find the ones place digit of the given question. And from the given options, our answer is option D, 6. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, if n factorial is a 2-digit number, find the unit digit of maximum value of n factorial. The given options are option A 4, option B 5, option C 6, option D 3. Before solving this question, I request you to please subscribe to this channel, as it is given that n factorial is a 2-digit number. So 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, and 4 factorial is 24, and 5 factorial is 120. But n factorial is a 2-digit number. It means that n is 4 and n factorial equal to 4 factorial. 4 factorial has value 24 and unit digit of 4 factorial is 4. And from the given options, our answer is option A 4. This is very easy question. We could have solved it without writing all these, as we know that n factorial is a 2-digit number and only 2-digit number is a 4 factorial. Up to 3 factorial all are 1-digit number, and after 5 factorial the number of digits are more than 2 digits. I hope you have understood the solution and method of solving such type of questions. We go to the next question. Our question is, n factorial is a 3-digit number. Find the digit at hundreds place of difference of maximum and minimum values of n factorial. The given options are option A 4, option B 5, option C 6, option D 8. Before solving this question, I request you to please subscribe to this channel. 5 factorial is equal to 120. 6 factorial is equal to 720. And 7 factorial is 5040. So 5040 is a 4-digit number. And 4 factorial is 24, which is 2-digit number. So only 3-digit numbers are 5 factorial and 6 factorial. And their difference is 720 minus 120 equal to 600. And digit at hundreds place is 6. And from the given options, our answer is option C, 6. I hope you have understood the method of solving such type of question and solving the questions based on factorial. We go to the next question. Our question is, which of the following numbers is a perfect square? The given options are option A 62 factorial multiplied by 63 factorial, option B 63 factorial multiplied by 64 factorial, option C 64 factorial multiplied by 65 factorial, option D 65 factorial multiplied by 66 factorial. Before solving this question, I request you to please subscribe to this channel. In the given question, we have to select a number which is a perfect square and the other number on splitting becomes a perfect square, and we solve one by one. 62 factorial and 63 factorial. None of these two are perfect square. 62 is not perfect square and 63 is not perfect square. Option B, the number 63 is not perfect square, but 64 is a perfect square. So one number may be out of these four, that will be number at B. And number at C is 64 factorial and 65 factorial. Here 64 is a perfect square, but 65 is not a perfect square. So C can be the one of the numbers which can be a perfect square. And D, 65 factorial and 66 factorial, both 65 and 66 are not perfect square. So this cannot be the answer. Now we solve number at option B, 63 factorial multiplied by 64 factorial. Now 64 factorial can be splitted into 63 factorial and 64. So we write it as 63 factorial and 64 multiplied by 63 factorial. 64 factorial can be written as 64 into 63 factorial. Now 63 factorial multiplied by 63 factorial becomes 63 factorial square, and 64 can be written as 8 square. So the complete this number is 8 multiplied by 63 factorial whole square. So this number is a perfect square. And option C cannot be splitted like this. 64 is a perfect square, but 65 cannot be splitted in such a way so that it becomes a perfect square. So the only number at option B becomes a perfect square. And from the given options, our answer is option B, 63 factorial into 64 factorial. I hope you have understood the concept and method of solving such type of questions. We go to the next question. Our question is, if the unit digit of a factorial multiplied by b factorial multiplied by c factorial is 8. Then find a factorial plus b factorial plus c factorial equal to, and the given options are option A 7, option B 9, option C 31, option D 32. Before solving this question, I request you to please subscribe to this channel. 1 factorial equal to 1, 2 factorial equal to 2, 3 factorial equal to 6, and 4 factorial equal to 24. And product of more than factorial will have unit digit 0. So multiplication of any number more than 4 factorial will give the unit digit 0. So it can be only out of these 4 factorials, 1 factorial, 2 factorial, 3 factorial and 4 factorial. And on observing, if we have to have the ones place digit after multiplication 8, then that can be 1 factorial, 2 factorial and 4 factorial, or it can be 2 factorial, 3 factorial and 4 factorial. So we take both the options of 1 factorial, 2 factorial and 4 factorial, and 2 factorial, 3 factorial and 4 factorial. So 1 factorial is 1 multiplied by 2 factorial is 2 multiplied by 4 factorial is 24, and 24 times 2 is 48, and 48 times 1 is 48. This is 1 where we have the unit digit 8, and 2 factorial is 2, 3 factorial is 6 and 4 factorial is 24, and 2 multiplied by 6 multiplied by 24 gives 288, and both have unit digit 8. Now we have to find the sum. So sum of 1 plus 2 is 3 plus 24 is 27, but that is not our option. So we cannot take 1 factorial plus 2 factorial plus 4 factorial, that we cannot take. The next option is 2 factorial has value 2, 3 factorial has value 6 plus 4 factorial has value 24, and 2 plus 6 is 8, 8 plus 24 is 32, and this number is one of the options. So our answer is option D 32. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, what will be the digit at one's place of 1 factorial plus 2 factorial plus 3 factorial plus up to 100 factorial? The given options are option A 1, option B 3, option C 4, option D 9. Before solving this question, I request you to please subscribe to this channel. 1 factorial is 1, plus 2 factorial is 2, plus 3 factorial is 6, plus 4 factorial is 24, plus 5 factorial is 120, plus 6 factorial is 720, and this continues up to 100 factorial. We know that after 4 factorial, every factorial has unit digit or digit at one's place is 0. So if we add these numbers after 4 factorial, every one's place digit will be 0. So it is not going to give effect the sum of the other factorials. So we add 1 plus 2 is 3, plus 6 is 9, plus 4 of 24 which is 13, and then all other will be zeros. So this will be 13, and one's place digit will be 3. So this gives one's place digit 3. And from the given options, our answer is option B 3. I hope you have understood the method of solving such type of questions. This was very easy question. We go to the next question. Our question is, find the digit at tens place of 1 factorial plus 2 factorial plus 3 factorial plus up to 100 factorial. Option A 6, option B 5, option C 9, option D 1. Before solving this question, I request you to please subscribe to this channel. We have to find the digit at tens place of 1 factorial plus 2 factorial plus 3 factorial plus up to 100 factorial. 1 factorial equal to 1 factorial. 1 factorial equal to 1. 2 factorial equal to 2 and unit digit is also 2. 3 factorial equal to 6 and unit digit is 6. 4 factorial is equal to 24 and the digits up to tens place is 24. 5 factorial equal to 120 and the digit at tens and ones place is 20. 6 factorial is 720 and the digit at tens place and ones place are 20. 7 factorial equal to 5040. So we write the digits up to 10 place, which is 40. If you don't remember the value of 7 factorial, then what you have to do, you have just to multiply the 7 to the last two digits of 6 factorial, and last two digit of 6 factorial is 20. So if we multiply 7, 7 times 0 is 0 and 7 times 2 is 14, and we write only 4 because we have to find the digit at tens place. Now 8 factorial. We just multiply 8 to the last two digits of 7 factorial, which is 40. So 8 times 0 is 0 and 8 times 4 is 32. So we write only 2 because we have to have the numbers up to 10 place. And 9 factorial. We just multiply 9 to the last two digits of 8 factorial, which is 20. 9 times 0 is 0 and 9 times 2 is 18, and we only write 8 of 18. And 10 factorial. If we multiply the last two digit of 9 factorial, which is 80, so 10 times 0 is 0 and 10 times 8 is 80. So we only write 0. Now we got the 0, 0 up to tens place. And if we multiply further 11 factorial to last these two 0, we will again get the 0, 0 up to tens place. Now we have to find the sum of these so that we can have the tens place digit. 1 plus 2 is 3 plus 6 is 9 plus 4 is 13 and all others are 0. So we write 3 and carry 1. 1 plus 2 is 3 plus 2 is 5 plus 2 is 7 plus 4 is 11 plus 2 is 13 plus 8 is 21 plus 0 is 21. So we write only 1 because we want to have the digit at tens place. So 21 has the digit 1 and we only write 1. So this becomes 13 and the tens place digit is just 1. So our answer is the tens place digit of 1 factorial plus 2 factorial plus 3 factorial up to 100 factorial is 1. And from the given options, our answer is option D 1. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the digit at ones place of 13 to the power 27 factorial multiplied by 24 to the power 52 factorial multiplied by 35 to the power 42 factorial multiplied by 49 to the power 63 factorial. The given options are option A 9, option B 5, option C 3, Option D 0. Before solving this question, I request you to please subscribe to this channel. Let us observe the digit at ones place of the given question of each constituent numbers. The first number is 13 and ones place digit is 3. Second number is 24 and ones place digit is 4. Third number is 35 and ones place digit is 5. Fourth number is 49 and ones place digit is 9. The other thing we have to keep in mind that every factorial which is more than 3 factorial is divisible by 4 and the remainder will be 0. So 27 factorial, 52 factorial, 42 factorial or 63 factorial all are divisible by 4 and the remainder will be 0. So we cannot take the remainder 0, we will take the remainder as 4. And every number at ones place repeats itself after every fourth power. So what will be the number at ones place when 24 to the power 4 is solved? 24 to the power 4 will give the ones place digit 6. And whatever may be the power of 5 in 35, it repeats itself and keeps it as 5. So 6 multiplied by 5 will give us 0. When 5 is multiplied to any even number, then ones place digit is always 0. So our answer will be 0. Now I will explain you after solving it. The ones place digit of 13 is 3 and its power will be 4. Multiplied by 24 as ones place digit 4 and its power will be 4, as all the factorials are completely divisible by 4. And third number is 35, the ones place digit is 5 and the power of 5 will be 4. Multiplied by 49 and ones place digit will be 9 and the power is 4. Now 3 to the power 4 will give ones place digit 1, as 3 to the power 4 is 81 and ones place digit is 1 in 81. 4 to the power 4 is 256 and ones place digit is 6 in 256. So we write 6. Multiplied by 5 to the power 4 and it will give ones place digit always 5. And 9 to the power 4 will give the ones place digit 1. As 9 to the power 4 can be written as 9 to the power 2 multiplied by 9 to the power 2. And 9 to the power 2 is 81 and 81 times 81 and ones place of 81 multiplied by ones place of 81 which is 1. 1 multiplied by 1 is 1. Now 6 multiplied by 5 is 30 and 30 times 1 is 30 and again 30 times 1 is 30. So ones place digit will be 0 as 30 has ones place 0. So this gives the ones place digit equal to 0. Whenever we find any multiplication of 5 and if any number which comes in multiplication is even, then ones place digit will always be 0. Without solving this, we can easily say that the numbers after seeing 4 and 5 in 24 and 35, we can easily conclude that the ones place digit will be 0. And we can save the time for solving other questions in any competitive exams. And from the given options, our answer is option D 0. I hope you have understood the concept and method of solving such type of questions. We go to the next question. Our question is, what will be digit at ones place of 1 factorial square plus 2 factorial square plus 3 factorial square plus up to 100 factorial square? The given options are option A 6, option B 8, option C 7, option D 9. Before solving this question, I request you to please subscribe to this channel. Factorial 1 has value 1, so it is 1 square, plus factorial 2 has value 2, so it is 2 square, plus factorial 3 square. Factorial 3 has value 6, so it is 6 square, plus factorial 4 has value 24. So ones place of 24 is 4. So it is 4 square plus 5 square is 120. So it will be ones place of 120 is 0 and the square of 0 will be 0. And 6 factorial is 720. Again we are going to get 0. And we will get 0 on all the factorials which are above 4 factorial. So all will be having ones place 0 and square of 0 will be 0. So we are not counting those numbers. So this gives 1 square is 1 plus 2 square is 4 plus 6 square is 36 and ones place of 36 is 6 plus 4 square is 16 and ones place of 16 is 6. This gives 1 plus 4 is 5 plus 6 is 11 plus 6 is 17 and ones place of 17 is 7. So the unit digit of the given question or ones place digit of the given question is 7. And from the given options, our answer is option C, 7. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, what will be digit at ones place of 1 factorial raised to power 100 plus 2 factorial raised to power 99 plus 3 factorial raised to power 98 plus 99 factorial raised to power 2 plus 100 factorial raised to power 1. The given options are option A 9, option B 4, option C 6, option D 7. Before solving this question, I request you to please subscribe to this channel. As we know that the ones place digit of every factorial more than factorial 4 is 0. And the other property we know that whatever may be the unit digit, it repeats itself after every fourth power. So when the power is divisible by 4, we put the power as 4, and in other powers, whatever the remainder is there after dividing by 4, we put that power on the ones place digit of given number. Factorial 1 raised to power 100. The value of factorial 1 is 1, and whatever may be the power of 1, 1 remains 1 in every power, plus factorial 2 has value 2, and the power 99 when divided by 4 leaves remainder 3, as 24 times 4 is 96 and 99 minus 96 is 3, plus 3 factorial has value 6 and ones place digit of 6 is 6, and the power of 3 factorial is 98, which when divided by 4 leaves remainder 2, as 24 times 4 is 96, 98 minus 96 is 2, and after 3 factorial there will be 4 factorial to the power 97, and 97 when divided by 4 leaves remainder 1. 24 times 4 is 96 and 97 minus 96 is 1. So 4 to the power 1. And after this power, 5 factorial has ones place 0, as the value of 5 factorial is 120 and ones place of 120 is 0. And all other factorial after 5 all have the ones place digit 0, and whatever may be the power of 0 will give the ones place digit 0. So we will consider up to factorial 4, and we have already written all the numbers up to factorial 4. We write 1 as it is, plus 2 to the power 3 gives us 8, plus 6 to the power 2 is 36, and ones place digit of 36 is 6, plus 4 to the power 1 is 4. On adding we get 1 plus 8 is 9, 9 plus 6 is 15, and 15 plus 4 is 19, and ones place digit of 19 is 9. Thus the ones place digit of the given question comes out to be 9. And from the given options, our answer is option A, 9. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the digit at ones place of 23 raised to power 1 factorial plus 2 factorial plus 3 factorial plus up to 10 factorial plus 39 raised to power 1 factorial plus 2 factorial plus 3 factorial plus up to 10 factorial plus 57 raised to power 1 factorial plus 2 factorial plus 3 factorial plus up to 10 factorial. Here the numbers 23, 39 and 57 all have power from 1 factorial plus up to 10 factorial. The given options are option A 7, option B 9, option C 3, option D 8. Before solving this question, I request you to please subscribe to this channel. We know that ones place digit of any number repeats itself after every fourth power. Therefore, we have to find the value of power of each number 23, 39 and 57. We also know that factorial 4 and all above factorial are divisible by 4, and whenever we divide that by 4, the remainder is 0. So we have to find the value of 1 factorial plus 2 factorial plus 3 factorial. 1 factorial is 1 plus 2 factorial is 2 plus 3 factorial is 6, and this is equal to 9. And 9 when divided by 2 leaves the remainder 1. 4 times 2 is 8 and 9 minus 8 gives the remainder 1. So we can write 23 has ones place digit 3 and it has power 1 plus 39 has ones place digit 9 and it also has power 1 plus 57 has ones place digit 7 and it has also power 1. So this gives 3 plus 9 plus 7. 3 plus 9 is 12. 12 plus 7 is 19 and ones place digit of 19 is 9. Therefore, the given question has ones place digit 9. And from the given options, our answer is option B 9. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the unit digit of 16 factorial raised to power 10 factorial. The given options are option A 6, option B 4, option C 8, option D 0. Before solving this question, I request you to please subscribe to this channel. The given question is 16 factorial to the power 10 factorial, and we have to find the unit digit of this question. We know that unit digit of any factorial which is more than 4 factorial is 0. So it will be 0 to the power 10 factorial. If the unit digit of any number is 0, then whatever may be the power of it, the ones place digit or unit digit will always be 0. This was that easy question. And from the given options, our answer is option D 0. I hope you have understood the concept and method of solving this question. Here completes this video. Please like, share and subscribe to this channel, and don't forget to press the bell icon to get the latest notifications. Thanks for watching.